Assalamu alaikum my dear students. Today I would tell you about the hyperkalemia and what effect does it causes on the resting membrane potential, on the excitability of the membrane, on the amplitude, on the threshold, on the intensity of the stimulus, and on the duration. So all of these aspects would be discussed in this lecture. So first of all, drawing the graph of the action potential like this. Now I am drawing with respect to the hyperkalemia like this. So now in the case of hyperkalemia, what actually happens that potassium ions are accumulated in the extracellular fluid. So less number of potassium ion would move from the membrane into the extracellular fluid with less velocity because already potassium ions are accumulated in the extracellular fluid. So that's why the resting membrane potential would decrease. The resting membrane potential would decrease, and it would decrease to minus 80. Let's say it decreased to minus 80 like this. Now why it has decreased? Because the potassium ions are already in abundance outside in the extracellular fluid as compared to the membrane. So less number of potassium ions would move out with less velocity. So that's why now resting membrane potential has become minus 80, and you can also see that the distance between them has also decreased. So now because less number of potassium ions have moved out of the membrane, so the resting membrane potential would decrease and it would turn to more positive. It would turn to minus 80. So writing the first point, resting membrane potential would decrease and it would become more positive because potassium ions are not moving outside as extracellular fluid is already has been accumulated with the potassium ions. So now you can see that the distance between the this in the case of hyperkalemia between the resting membrane potential and the threshold is very much less. So that's why this membrane is said to be hyperexcitable. Hyperexcitability. In the case of hypokalemia, it was hypoexcitable, but in this case, it is hyperexcitability. Now you can see that the distance between this threshold and resting membrane potential is very much less. So a very weak stimulus is enough, very weak stimulus is enough to reach that threshold. So that's why this membrane is already hyperexcitable, and a very weak stimulus would bring up the threshold and would carry on this action potential to propel. So now talking about the threshold. So threshold would also decrease as the distance is very much less. And talking about the intensity of the stimulus, so weak stimulus would be enough to reach that value of threshold. Furthermore, talking about the amplitude. So talking about the amplitude, you are saying that as weak stimulus is enough to reach the threshold level, so if the stimulus would be weak, so that's why the amplitude would be very much less. So amplitude would be very much less. So that's why the reason I have told you the amplitude would be less, because very weak stimulus has been you can say given in this hyperkalemia condition. So that's why the amplitude would be very much less. And talking about the duration, so the duration would be long because potassium ions are not moving with that much pace from the membrane into the extracellular fluid, because already extracellular fluid is accumulated with the potassium ions. So now that's why the duration would be more. That's why the duration of this propagation would be more, because potassium ions are coming out with less space from the membrane into the extracellular fluid because potassium ions are already accumulated there. And if we talk about the propagation, so the propagation would be slow propagation. That's why the propagation would be slow in the case of hyperkalemia.
So in this particular lecture, I've explained you about the hyperkalemia and what effect does it cause on the resting membrane potential, on the threshold level, on the intensity of the stimulus, on the amplitude, on the duration, and on the propagation. So last but not the least, don't forget subscribe to MS Lectures. Thank you.